solve a division problem using something called partial quotients. And it's really easy to use, and sometimes it kind of helps take the guesswork out of some division, okay? It's not the most efficient way to solve a division problem, but it'll get you where you need to be. So let's take a look at our scenario. People in the United States eat about 23 pounds of pizza per person every year. Think about what that means. Oh my gosh. People. That just means like most people eat about 23 pounds of pizza per year. I would say that's almost true. I order pizza all the time. I really do. Almost every Friday or every weekend I order pizza, at least for my kids. I may not always eat it, but I know for sure that's probably true. I would even venture to say it's more. But anyway, moving along. If you ate that much pizza, so let's just assume that Ms. Kanak eats about 23 pounds of pizza per year. How many years would it take me to have eaten 775 pounds of pizza? Wow. Whew. Let's take a look at this. Okay, so this is a classic division problem. Okay, so in our division problem, we're going to have, I'm going to set it up this way. What I'm going to do is I'm going to extend this little bar down this way. And this is where I'm going to collect all my partial quotients. So 775 divided by 23. Okay, so one of the things to do is whenever we are using partial quotients, basically what we're doing is we're subtracting multiples of the divisor. Okay, if you remember what multiples are, it's the two numbers you multiply together to get a factor. So we're just multiplying multiples of 23, and we're going to subtract them from the remaining number. So the easiest partial quotient to use when you're dealing with big numbers like this is to start with 10. It's honestly the easiest one you can possibly use. Start with good old-fashioned 10. So we're going to go. And again, it kind of still follows the same process. Does McDonald's sell burgers? We're going to make a division decision, which we kind of already did. We're not sure where to start, so we're going to start with 10. So I'm just going to kind of collect my multiplication on the side here. So I did my division, which I decided on 10. Now I'm going to do my multiplication times 23. Well, since you know how to trail zeros, this problem is so easy. It's going to be the product of 230. So we did our multiplication. Now we get to do subtraction. So now I'm going to take 775 minus 230. Okay? And so we end up with 545 because 5 minus 0 is 5, 7 minus 3 is 4, 7 minus 2 is 5. Okay, now we're dividing 23 into 445. I'm going to choose 10 again. Why not, guys? We got a good thing going with 10. Let's use it, right? So 10 times 23 is again 230. So we made our division decision. Now we're multiplying. Let's do a little subtracting, shall we? So 5 minus 0 is 5. 4 minus 3 is 1. 5 minus 2 is 3. All right. Good, good, good. We're doing great. All right. So we're going to do it again. All right. So why not use 10 again, right? Why not? Why couldn't we? 10 times 23, again, 230. I like to just make this. You don't have to make that list on this side if you don't want to. You can just do it like this. But I like to keep it because I don't know, it just makes me feel warm and fuzzy. Remember how I told you earlier that division is really repeated subtraction? Look what we're doing each time when we're using our partial quotients. Pretty cool, huh? All right, we're going to keep doing this. So 5 minus 0 is 5. Here I've got to do a little regrouping. So 11 minus 3 is 8. And now 2 minus 2 is 0. Now we're at a crossroads here because now I can no longer use 10, can I? Because because the product 10 times 23 is 230, which is going to be way too big to subtract from 85. So I'm going to have to back it down a little bit, okay? I'm going to have to back it down just a smidge, okay? So if I used 5, here's what I've got to think about, okay? I know that 5 times 20 is already 100. Well, 23 is bigger than 20, so I can't use 5. I'm going to have to go even smaller. Well, even if I used 4, I know that 4 times 20 is 80, but we're dealing with 23. So that means that 4 times 23 is still going to be too big, right? So I'm going to back it down to 3, okay? So 3 times 23, okay? And if you want, you can go off to the side. If you're not exactly sure what it is, it's no big deal. You can come off to the side. 3 times 3 is 9. 3 times 2 is 6. So the product is 69. Now I can do my subtraction. Now again, I've got a little bit of regrouping I've got to do here. Okay, so 15 minus 9 is 6. And then 7 minus 6 is 1. So we have some remainder. We've got a little bit left over. We have 16 left over. Because I know that I'm done because now I'm at a point where 23, it ain't going to fit into 16 anymore. We're done. We've got to stop. Now the next question is, well, okay, that's all great, Ms. Knack, but what's my quotient? I'm going to show you what your quotient is. You see how we chose 10, 10, 10, and 3? You see this? Look at that, 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 guys. Look at that. All I'm going to do is add those together. 10, 20, 30. 30 plus 3 is, you guessed it, 33. So our quotient is 33. Remainder. How do we show our remainders like a 5th grader? If you said as a fraction, you are right. Remainder, 16 over 23. So our quotient is 33, remainder 16 over 23. This is just one strategy that you can use, and it works for just about any problem that you ever want to try. So I encourage you today during your independent work, try this out. It does work. No, it isn't the most efficient way of doing it, but it gets you to where you need to be. And 10 is a super easy number to use. So you might as well try it out and see, because it will get you where you need to be if it works for you. There's no shame in your game for using partial quotients.